Okay, so me and a few friends decided to get some planes for winter FPVing. Um, so we got the Hobby King Skipper XL because it takes off from the snow and lands on the snow. And you can sit in your car and not have to stand outside to launch it or sit outside or walk backwards while flying something line of sight before you put your goggles on, because that's what I've done at least when I fly wings. So this video is really going to cover some information for me and my friends. I'm first. I'm ahead of them, so this is to help them build their planes. I'm not going to cover basic clean flight or baseline stuff or naze stuff. Calibrating, setting up your receiver tab, CLI, all that stuff. I'm not going to cover that. There's so much information out there. This is really specific to our planes, the Skipper XL, and although some of the information definitely can apply to other planes as well, because it's really to help my buddies get going with the plane build. So we will not be using GPS, although that's certainly a possibility later on, and that's something that you can add. And supposedly Baselight works pretty well with GPS and return to home and all that. So, but we won't be doing that. I'm just going to be using this for stabilization. In fact, all of us may not be using a naze for stabilization, but I think in terms of fail-safe, self-leveling is pretty good as it glides down. Hopefully that's the case. We'll see if that really works or not. So, alright, here we go. For the Skipper XL, the FPV that we're building, this is for me and our buddies who are building a few of these for winter FPVing. I'm going to use the naze board. This is an older board with the pins already soldered vertical because I got plenty of space, I think. So we're going to use this for stabilizing the plane. And I'm going to use my trusty, or the trusty, Lemon 8-channel ppm receiver. And it's plugged in the right place. This is just to power the board, and then VBAT just to test that out. Hopefully it doesn't fry. So here we go. We're going to bind this. Okay. Flashing. Bind. Okay, so I'm gonna have the beeper on, stabilize mode, throttle, well, let's put throttle down at 0 for now, and if I'm gonna have LED lights, we'll have those on, full rates. And this is how you do the fail-safe on this thing. So you put your switches where you want to be on all 8 channels, and you push this green light means you have fail-safe. Alright, so unplug the bind plug. There we go. Self-level off. Oh jeez, it doesn't recognize.
Hammerhead rate. Normal mode.
I probably have to set that in the oh, there we go. Oh, I have self-level on that one. Okay, well, I have to set that in. So we're going to flash this with base flight, and set it to fixed wing. And then I'm going to hook up the servos and make sure that they work. And then I'm going to move this and make sure the servos are going in the right way. I'm going to put beeper right here where it's supposed to go. And RxTX, I will have an OSD just for voltage. On a plane, artificial horizon might be a good thing too. So we'll see about that. Right. Okay, so I soldered this ESC. I'm going to use the onboard BEC. Supposedly it's capable of 4 amps. It's 5.5 volts, which is just the cutoff. I've read that the naze can only take up to 5.5. Anything above that, like 6 volts, it doesn't like. So you'll notice I put 2 JSTs on here, and that is obviously one is for VBAT, and then one is for like a 12 volt voltage regulator for FPV equipment. Or if you want, you can just use if you don't want to use the onboard, you can use an external BEC, and then you can remove this red wire, but then you'll have to power this thing anyway. So I think this onboard BEC is going to work just fine. And then I'm going to use this for converting to 12 volts for the FPV equipment, or I'll try to use FPV stuff that takes 4 cells straight, which a lot of stuff does these days. So and then this will just be left over for whatever I want to use it for. Who knows, GPS or something in the future, who knows, but we'll leave it like that. Okay, we are in base flight and we're going to calibrate the ESC like we always do, even though it's not Simon K or BL Heli or anything. In fact, I read that you don't want to use Simon K because, shoot, the shrink wrap on this battery, because the fast torque changes will cause torque roll. The regular airplane ESCs have a smoothing algorithm. You know, there's a buffer for the changes in throttle, so that way it's smoother and you don't have weird instant torque rolls. So we're gonna leave the firmware on the ESC as is. Okay, so I've gone into base flight, into the motor tab. I've checked the box. I set my max throttle at 2000 and my min command at 1000. So I'm gonna set the master slider to max, and only motor 1, since this is set to airplane mode. Oh yeah, so I set it to airplane mode. Go to motor 1. I'm sorry, increase the throttle, master throttle, and then motor 1 goes up to the top. Obviously there's no motor 2, 3, or 4, so here we go. Okay, wow, that was a lot of torque on this motor. It really kicked. So I've calibrated. Let's try. Oh, that's right, usually you have to disconnect and reconnect. Okay, 4 tones, 4 cell. Oh, it starts right off at 1050, huh? And that's 1100. So I think I'll reduce the min throttle to 1050. Wow. That's got some good power, okay. So, oh, one other tip is, let's disconnect this. Oh, jeez. There's 2 grub screws in this housing, in this motor bell. One of them was kind of loose, one of them was pretty tight. So what I generally do is, if there's grub screws in the motor bell, I'll try to loosen them with a little bit of force. And if I can't, I'll leave it alone. If I can, then I'll obviously take it out and Loctite it. So that's what I did. I have yet to. I always lube new motor bearings. I haven't done that yet, so I have a little needle luber, and I'll stick it in there, and then put some in here too, and I'll lube it. So, and this motor may need some balancing, but man, it's kind of loud. So good power though, lots of torque. Okay, and then we'll get on to the rest of the setup. What did I do last night? We got our naze plugged in, got base flight installed. Oh, downloaded a specific version because there's one of the latest versions, at least according to the site that I'm kind of following as a guide, said that there's some issues with the latest, so I downloaded the one he recommended. It's a specific hex or bin or whatever, it's a hex file, so I installed that firmware. I'll put that link in the description. Okay, got my naze hooked up, base flight, got my receiver, turn on the radio, and what I discovered yesterday. So let's do this. And you'll hear the servos sometimes buzzing. Digital servos do that, no worry. Alright, so here's the thing. In the servos, so just like a quad, and I'm going to assume you've used clean flight or base flight, and if you haven't, please go look at the other tutorials, because I'm not going to cover all that. That's a lot of stuff. But if you set up a quad, you've got to set up the receiver tab. You have to set all your signals to 1500 in the middle, and then 1000 and 2000 at the endpoints. I've already done that, but here's what was happening. So I take a look at this aileron servo, and I'll set it back to the way it was. See that? It's not quite lined up. It's not, it's a little off to the servo itself. And for an airplane, you want that to be, either parallel or 90 degrees or whatever. So if you mess with a sub trim in your radio, you can fix that, but then your center position isn't 1500 anymore. So the way you do it is you go into the servos tab in base flight, and there's gonna be a servo 3, 4, 5, and 6. The numbering's kind of off. All you have to know is that these are the 4 servos in the order that you plugged into your board. And I only have 3, but I'll show you that in a second. So I'm gonna skip servo 3. Since this plane only uses 1 aileron servo, I only have 1 servo. I happen to be using servo 4. You can use servo 3 if you want, because it's still gonna move in the same direction. But I just use 4. So servo 4, I already have that number set. You set your middle value, it'll say 1500, and I set it to something like, first you plug in the servo, let it get centered as close as possible, and then install your horn and as close to perpendicular as you can. And then you go into the servo tab in base flight, change the middle position. I have, instead of 1500, 1585. And you have to kind of play with this. Enter a number, save, enter a number, save. It doesn't take too long. There's this live mode. Oh, look at that, it does work. It didn't work for me yesterday, but let me try this. 1500. Oh, yeah. Okay. 1585 works for me. Enter. Look at that. Okay, it works perfect. Save. And you can see it's fairly square. Do the same for your rudder and aileron servo. This is, again, specific to the Skipper XL from Hobby King that I'm setting up, but same applies for any plane. So I did the same for this one is the rudder. Let me see. Yeah, rudder. Rudder servo. Let's focus. See, pretty much square. And elevator. I'm not going to show that to you. Let's point. All right. Yeah. That's the other thing. So again, so you can see. Can you see it? I've got them plugged into the first one. There's 6 ports on your naze. The first one is the ESC, and which is kind of cool because you can, if you hook up a GPS to this, you can have it control the motor on failsafe. So, but we're not going to do that part. I may do that later in another video. That's a whole nother setup. I haven't actually tried it. So for this one, we're just going to use the stabilization, no GPS and return to home function. So this is aileron. Second one is rudder. Last one's elevator. And I just took a Sharpie and put a single tick mark, 2 tick marks, and 3 tick marks, so I know which order they go in. On the servo wire, so I know which one's rudder and elevator. The mapping here is obvious. And of course those are on ppm. So here's another thing that happened. Obviously the servos are moving when I move the board, and that's what's supposed to happen. But yesterday what was happening is the defaults, when you go into the PID tab, are really high. It's like 4 for the proportional, 35 for I, and D was like 23. So right now I've got P's at 1.5 all around, and this is just starting with, I'm going to have to tune this. Everybody's going to have to tune their own. I's at 0.015, I got D's at 0. So if I put the D's back up to 23, which is what they were before, and save, here's what was happening. I just moved the board a little. See that? Shattering like crazy. And it's not supposed to do that, so let's go. Look at that. I'm not even touching it. It's just a vibration on the desk. There. See that? These are at 0. And now if you move the board, now this is going to be the hard thing to see because it's going to happen quickly. Oh, first, you have to imagine this servo mounted in the plane. There's a link going beneath the plane, and this is all going to depend on how the mechanics are. So if you have a link going above, it's going to be a little different. So if you imagine this link going down, hooked up to the aileron from the bottom. So what happens is when you give it right stick on your radio, and my radio's off screen, but I give it right stick, servo moves like that. So imagine this pushing on the link, making the aileron go up, which makes the right wing dip down. So that's correct. If that's not correct, if I go right and it's going counterclockwise, you have to reverse that servo in the radio. Okay, and then redo your center and endpoints. So first do your reversing, then do your centering and endpoints in base flight. Now here's the tricky part. How do you know if the gyro is operating in the correct direction? Well, it is. I didn't have to reverse it. There is a way to reverse it if you have to, but let's see, that is again in the servos tab. Each servo has a reverse direction of movement, but I didn't have to do that. So if I move the gyro quickly to the right, or let's say to the left, so we know what right looks like. This is the right direction. If I move the board, roll left, it should go in the right. The servo should counteract it. And it's going to be quickly. It's going to be a one-time thing. See that? Left, and it goes right. And then the opposite is also true. If I roll the board right, the servo wants to go left for a moment to try to counteract it. So you'll notice it doesn't stay. Well, of course not. It's not in any kind of heading hold. If I flick to horizon, now it'll stay. So it's gonna try to hold that position. So if I move the board to the right, it's gonna try to keep going left until the plane stabilizes. Same thing to the left. If the wind moves the plane left, rolls it left, the servo stays there until the board is fixed to the position it thinks it should be. Do the same test for yaw. You just roll. Oh, yaw, that's right. Yaw is not included, obviously, in horizon mode. If it were, if you've ever used a gyro on rudder, you only use it for takeoff on a plane. Because after that, if you try to use the rudder gyro on a rudder when trying to turn or bank, it's gonna make it crash. So the rudder is always in rate mode. Okay, elevator's a different story. So it's going to try to fix. So this elevator is going to be mounted. Oh, you couldn't even see that. So this elevator will be mounted on the plane like this. Push rod goes down beneath the elevator control surface. So for the elevator, it's going to want to, if you want to go up, it has to move this way, which means this has to move backwards. So I'm going to pull back on the elevator stick, and that's the way it works. And then I already checked the gyro directions. And then you do the same for rudder. The rudder on this plane is going out the left side. So if this is going to push on the left side to go right, rudder right, this servo horn has to move down. And it does. And then lift, it goes up. So you got to check all those directions. And again, reversing the radio. So there's two things you have to check for reversing. Number one is the movement based on your stick that you reverse in the radio. And then there's the gyro movement that it's compensating for, and that's done in base flight. So D's at 0, I's really low, P's about 1.5. I set my roll and pitch and yaw rate to 1. I set the expo in base flight to about 30. You don't want like 70 like we do on the quads. That's just way too much. You can if you want, but I think that's not a good habit to get into. The level P's, so you can hear the servos buzzing because they're digital. The level P's we'll have to tune when we fly it. What else? Servos. Oh, the servos, you'll see that it says min is 1020. I left that alone. I tried making it 1000, and it looked a little weird. It wasn't even travel when you go from left to right, so I left it at 1020. I think that's to compensate for something. I don't know what it is, but it works. Okay, mode selection. Alright, you cannot arm this with a rudder because there are times when you're going to be at 0 throttle and you may use your rudder. If you arm with the rudder, you may fall out of the sky because you won't have motor anymore. Because remember, in order to use the motor on this with the base flight, you have to have it armed. So arm on a switch, and that depends on your radio, but I use my throttle hold switches, which is, so as soon as I disable throttle hold, I'm armed, which is what it should be. If you also use throttle hold in your radio, I know Spectrum likes to set it at negative 130%. Make that negative 100%. or 99 or something. Because if you go negative 130, you're going beyond the throttle position that, you know, of 1000. You're going below that you set in naze. Anytime you do that on any of the channels, you go into failsafe. Okay, and that means wherever you set your failsafe throttle and your sticks and self level and all that, it's going to go into. So you don't want to do that. You only want to kill the throttle, so set it to negative 100%. My aux2 switch I set to horizon mode. I may set what's called a pass-through mode. So I'm going to have 3 modes. One is regular stabilization, like acro mode on a quad, and one will be horizon for self-leveling, good for fail-safe if I have to, you know, whatever fail-safe, loss of signal or whatever. So it'll hopefully just self-level and then land. We'll see how that works. And then we'll see about pass-through mode, which is no gyro interaction at all. And then aux3, just like a quad, I set the beeper. I haven't hooked up my beeper yet. aux4 is going to be my OST switch, so I can switch between having horizon and just seeing voltage and time. So that is it. Let's see. Let's go over the configuration tab. Just like a quad, I used ppm, enable VBAT. This is a little different than clean flight. You just have to look for it. Failsafe setting enable. I set my failsafe throttle to something below regular, like 1050, which is just above 1000 in my min command. Let's see, so because I don't want the plane to just fly away somewhere. Motor stop. I set my voltage scale as usual. Obviously set it to airplane mode. You also want to set your RC rate to 1. Oh, I have my RC expo as 40. Okay, that's fine. So this is a little different than quad. So you want full movement on the servos, and the best way to do it is to control your surface throws is to do it mechanically. In other words, you know, put the link. If you want more throw, you put this link on the outside, and then a link on the control horn for your aileron, for example, low or on the inside. That gives you the most throw, but less resolution. So more resolution, less throw. You move this one on the inside and the other one on the outside, and then that'll give you more accuracy, but not as much movement. So you want to do that part mechanically. You always want to try to use as much of your servo throw at 100% as possible. You can also go over 100%, but then at the end point, the gyro has no headroom, no room for compensation. So 100 to 100. If you have to, you can use dual rates and go 80 to 80 or so. But that's you can tune that while you fly. After you figure it out using dual rates, you really should go back to 100% and then fix it mechanically. That's ideal.